it's going to be always smooth, then you can always swap derivatives.
What do you mean by smooth? Okay.
Not like,
It's like waves.
Like
Yeah.
waves.
yep. So always,
the height
if you
equation.
have u, x, y, x, x,
We have
You can
waves equation.
Yeah. بعدين
Engineers.
وين؟
Yeah.
yeah, you can, this is,
Swap.
you can just swap. However it best
Yeah,
it
but
works
like
best for
this
you.
one.
Yes.
ترجع لي تشرح لك الحين
Okay, go ahead.
And then again, ut is uxx, so you have uxx and xx because here. Basically, you want, like, you can have gone
Just have
faster.
target.
1t is 2x,
Okay.
yes? So, how many t's do you have here? 2.
It always will be the same.
What?
I mean this one, like this one. It will be the same like this one.
No, in this, only in this example, we
Ah,
know
in
that
this
this is equal to this.
Like
Yes.
it will be given in the question.
Yes.
Okay.
But you can always swap. Swap? You can always swap.
Okay.
But only in this example, 1t equals to 2x. So we have 2t's, and 1t is 2x, so we have 2t's, it's going to be 4x's.
Yeah.
Yes? Okay. So, because we have this, yes? Then this bit, yes? L delta u, this is exactly this. So just going to work 1, 2, 3, 4. And then delta t over 2 minus delta x squared over 12, and then O of delta t2 delta x squared.
All of them just for this one.
Just your explanation. But basically, this one step, this one,
Okay.
not everything.
Yeah.
Yes? Okay. So now, you know that this, it has like, this is the error. And you want this to be the minimum possible. So what we're going to choose, we want to be minimum. Yes? So we'll choose this to be 0. So then the order is square 4 instead of 1, 2.
Yeah.
Because if this is non-zero, then we can just, if this is non-zero, yes, this is basically O of t, t delta x squared. Yes? No, square. Yes? So if this is non-zero, then this exists. So this is this.
Yeah, that
But
one.
without this one, because it doesn't really matter. Because you always take the smallest,
This one.
you know? You don't take the biggest ones.
Yeah.
But if this is 0, then the error is this one. And what do you prefer, this error or this error? This one, because it has like higher powers. And these are going to be smaller than 1. So the higher powers, the better for the error. So you'll choose delta t over 2 minus delta x squared over 12 to be 0 to have the smallest error. Yep. This is the
Have the smallest
error because you have either this error
Yeah.
or this error.
Okay.
Yes, and this one is smaller. If this is 0,
Yeah.
you only have this error. Yep.
Carla,
Yeah.
you explained last week if comma or not.
Yeah, comma.
Same comma.
Comma.
Always comma.
Always comma. Yes.
Okay, if this one, how can you know this equals you?
Because you can choose delta t and delta x because this is your grid.
Yeah.
Yes. So this is like
This is delta x.
this is delta x, and this is
Delta T.
0, this is 1,
Yeah.
and this is x0, and this is xj.
Okay.
Yes.
Yeah.
So you are given j,
Yeah.
and we said the other day that delta x is 1 over j.
Yeah.
Yes, because
okay.
it's all just divided into. Yes. So if this is this, then you can choose delta t.
Yeah.
Yes. So it's going to be like delta t over 2 minus squared. This is 1 over j squared 12 equal to 0. Yes. Yeah.
Okay.
Okay. So number 1, number 2, and this is basically going to be delta t is going to be 1 over j square 6. Yes, this goes here, and this 2 is up with 12, 6.
Yeah, yeah.
So if you choose your delta t to be this time step, delta t is just the time when you measure the things. So you can measure the things every 1 minute, every half minute, every third minute. Yes. So if j, I don't know, if j is 2, yes. Okay. Then delta t is 4 per 6, 24. Yes. So you choose this time step. So this is going to be 0. So the error is going to be even smaller than if this one wasn't 0.
And this is the error.
Yes. And you want the error to be smaller, the smaller
Yeah.
possible,
And this
because
is,
you're making an approximation.
this is it rule like 1 over g.
Yes. And why basically? Because
Because
This-
all of it is G.
yes, 0
give me
and
this
1,
just this one.
and you have j
over
partitions,
1
and
over
this length over partitions.
عندك الجزئيات.
ثابتة هاي ثابتة قانون
قانون.
يعني تعطيك ستيب هذا السيس.
اي بس كيف ليش ربعت التربية هنا على دي؟ القانون هنا.
أو
What do you
10
want?
دي اكس.
أنا أتوقع درسناها. We have studied this last lecture, last class.
ماشي mention just
No,
delta
no,
t square.
I don't think she said anything,
No, just
but she said we want this to be 0.
delta
Yes.
t. She focus for this.
So how do you make this equal to 0? Because delta x is fixed, but delta t is not fixed. You can measure every time you want. But delta t, once you divided your 0-1 interval, then delta t is fixed. So if delta t is fixed, you only can choose delta t. So choose this one, and then this is going to be 0, and then you have a smallest error.
The best to choose delta h or not delta x.
اكس خلينا قبل واحد على جي. طول هذا واحد العدد الستيب.
إيه.
أخذ الفترة هذه طبقتها هنا في القانون هذا.
هذا نفس
12
10.
هذه 12 هذه 12.
اي كتبت على كذا.
بدالها تحصل هذه. بعدين هي حلتها بالطريقة هنا. حصلت
إيه.
إن طول الستيب هذا لازم يكون 1 على 24 عشان يكون هذا صفر. إذا جاء صفر ناخذ هذه.
اي.
Yep.
اي.
So yeah, and like they are going also to ask us always calculate this error. In this error means this. Yes. When they ask you calculate
LTE.
LTE, you want O of delta t to the p, delta x to the q. That's it.
Always.
Okay, okay. The error.
Yes. And then they are always going to tell you which scheme which scheme are you
Use.
going to use, because you need the scheme to make
FTC.
this L delta. Yes. In this case we make this. Why? Because they told us that the scheme is going to be FTCS. If they are going to tell us no, the scheme is CTCS, instead of this we would have used the central, and instead of this, central, and then the tailor would change. Yeah. yeah, basically is all the things here.
It's the matrix.
Yeah, and then when there's two concepts, one is consistency. So LT, well, your scheme, like, is consistent if the LTE goes to 0 as delta t delta x goes to 0. Our scheme was which one? So our scheme was FT S CS. Is consistent? Yes, because as we make this go to 0, this also go to 0, so this goes to 0. So it's consistent. Yes? And then there's the order. Yes? So the order of the scheme, yes, the order of LTE is P in time and Q
Space.
in space. Yes, and that's it. And now we start with the matrix, which is what we started today. Yeah? We can continue a little bit. Like, I think we have time.
Yeah, 10 minutes.
I don't know. So, this is local, yes? So it's like this drawing she just made today. So you are at this point, u of xt, and you move to u x, I think it was,
T capital.
yeah, I think it was t plus delta t, yes? You move, yes? But then you are going to approximate it with this w, yeah? So this is your local error, yes? And every time you do this, so let's say you start here. Yes? This error.
Okay.
But then
Would be
the
bigger.
error can be twice. It can be smaller, okay, but the error can be between. This can be from here to here. This one from here to here. But it can be here, which is maximum. You don't want this. Yes, because then your approximation is just going to diverge the original, and this is not good. Yes? Like, this is good if you want just one time step, because it's just like one. But if you want to do a lot of them, then it's not good if we don't have like stability. Because in the stability, it's like the same, you know? One point is stable if all the points go to them. Yes? So what we want that instead of a point now, we have u as a solution, as a point. And we want the w, we want u, sorry, to be stable, kind of. So all the w's will go to u, not go away from.
All approximate.
This one W.
Yes,
All the approximate going to exact.
to u. Yes.
To exact.
So
Yeah.
all these points,
Yeah.
I want them to, like this, to be, like, at least not to go away,
Yeah.
you know? And how are we going to do it? So, in the case where we had that FTCS, yes, we have W j n plus 1 is going to be equal r w j n plus 1 minus 2r yes, and this is just like you can put this in a matrix.
Yeah.
Yes, so it's going to be look. So you have w n plus 1, which is basically w1 n plus 1 w j minus 1 n plus 1. And this is the vector. And then this is going to multiply it by a matrix. Yes, going to call it A, and then n plus extra terms. Yes, and you need the initial condition, so you need w of 0. Yes, so because if we put here 0, you have here 0. So w of 0 is just basically this of a time 0. Yes, and what was this? This was just basically f, the function f of what? At the points. So big X, which is basically f of x1 till f of xj minus.
Carla, if you put 0 here or 1?
If you put here 0,
0, you give me 1.
gives you 1. But then here is 0.
Zero.
So you need the 0.
0 put
So
out.
you need the initial condition.
And
Yes. This is the initial condition.
for this, for
Yes.
0.
Because if you want to keep doing this,
Mm.
you cannot put minus n here.
Okay.
You need to put
Start 0. 0, yeah.
So if you put here 0, here there's a 0.
0, yes.
0.
And what is this 0? You
This
need
mean
it.
this
Yes?
for A,
You
the
need
matrix. Yeah.
The initial condition.
Now when a B.
Okay. No, this is just the initial condition.
Yeah, initially.
I'm going to write the matrix now.
Alright.
Okay. So what's the matrix?
But she write today like line and down. What do you
Yeah.
mean? But
Okay. So this is the vector.
vector.
For me, it's capital.
Okay.
It's the same.
Yeah, it's the same.
For you same.
Yeah.
Dan كم في
You
مقالها.
can- If you want, I can put this.
Capital and line.
Okay. Dan كان. دين كان.
Okay. And what is A? So if you remember when we did this, well, this basically, if you put J, one number, what it depends? It depends on the same one, the forward one, and the previous one. Yes. So when you have to put the A, and you are in the first one, so the first one is going to depend on the first one.
W0.
Yes, which is, I'm saying, is 1. Yes, if this 1, here is going to be 1. So the number is 1 to R, and then it's going to depend on the next one, which is R. Yes, but this J minus 1, which is going to be 0, you cannot put it here.
You can put it.
Yes, so what you're going to do is you're going to put it in the B. Yes? You're going to put it in the B. And what is the B? It's going to be R, because you need this R, or this R, and W0, N. Yes?
Yes, yes.
Okay. The second one is the second one. So it's going to depend on 1, 2, and 3. So 1, 2, and 3. And this order because it's 1, 2, and 3. Well, 1, 2, and 3. Yes. The third one is going to depend.
And
Sorry,
2.
here is zeros. The third one is going to depend on 2, 3, 4.
Okay.
So 2, 3, and
4.
4, and then 0.
Here multiply or plus? I think
multiply.
multiply. Yeah.
And 1, 2, and
And
3, 1. Yes. Basically, it's this written as a matrix.
Yeah.
So it's basically this as a diagonal. Yes. Why diagonal in here? Because the j is the same here, so it's going to be the diagonal. Then in the upper diagonal is going to be an r, and in the lower diagonal is going to be another r. And at the points, at the initial and the end points, because you don't have a small space in the A, you're going to put it in the extra one. So the first one is going to have an extra one here. The second one is not going to have any extra because it already has the 3. The third one the same, and you go up until the last one, which is going to have the one that should be here. Yes. This one is this one that you don't have enough space. And this one, it's going to be in the last column because, of course, when you multiply, this is going to be in the last column. And this is going to be r, yes, because the same r here. But then w, n, and j plus 1. So j. Because it's the one that you don't have space to put in the matrix.
Yes, I have a question. Why remove r from here? Well, if we put like r, start from here, what's the problem? If we start matrix from here?
No, because that's why here. Because this is going to be W1.
W1. Yes.
So J1. If we put J1 here, you have J plus 1, J, and J minus 1.
Yes.
So this one is going to be 0.
Yes.
So you should have it here.
give this one and this one just.
Yes? But this one is not in our column. So you cannot put it here because you're going to multiply like this. You're going to put it here. This one is here. And again this, you don't have this one. So you cannot multiply them.
There will be.
You're going to multiply outside by adding this row.
Okay.
We will start from here to the end. This is the first
Beginning?
one, and this is the end.
Yeah. The ones that you cannot put in
Yeah,
the matrix
exactly.
are going to put separately.
Yeah. What ask about created this for matrix?
Sorry?
How created this? 1 minus 2r.
Because of these ones.
Okay. If you put 0 for example, or
0 where?
1
how can get 1 minus 2 3? No. How can get minus 1 minus 2r?
I don't understand.
This. How can get it?
1 minus 2r is because it's here.
Okay.
And these are just like
There is 0 here or no?
there's nothing.
Hmm.
The columns are
He ask you about how can you get this one from this one? But one in
like,
G, right?
for example, if you have this one and you multiply, and here it's going to be
I know.
the W
I agree.
n plus
Okay, but how can get 1 minus 2r? R 0 r like this. All this.
sorry, I don't understand.
How they get this 1 minus?
How?
Oh yeah. When you bring this 1 minus 2r in here,
Yes.
that's it.
Yeah, this is because this one is here.
Mm.
These are is because this one is here. And then this is because these ones are here. It's like the coefficients. Yes. This, this, and this are these ones.
You put 0, give me this.
And the coefficients are the matrix.
I got it. If I multiply by 1,
And then
And-
you just multiply
No,
This
no.
for this for this.
This coefficient here. This is 2. Yes.
يا اخي لما
Coefficient double G, and if you put W1 and okay, for example, this is second here. This one, yes.
انا هذا صورته من قبل.
Yeah, because if you
يوم
like, if you want to know, for example, the W and 2, yes, you're going to choose the second row.
This two second row.
كيف تسوي له
Because
ابلود؟
this 2
في جوالك تسوي
is
له
second
ابلود
row.
مقاطع
So
الفيديو.
you're going to multiply this with the second row.
Okay.
And this is first one. So this one, second one, 1 minus 2
Okay.
W and 2, and third one with this,
لا تسوي يوتيوب. ضايفه في القناة.
and then the rest of it is 0. So the rest is 0. And you don't care. So this
بس كذا
is
يعني
basically this in the case where J is 2.
Yes, yes. Okay.